All right, so that was a thing that happened. I ran into an issue where I left. So I'm doing these streams and I'm not announcing them really to anyone. And sometimes I get people watching and that's fine. But I'm doing this just to practice to see what issues crop up. This is like a shakedown cruise for my live streams to see what issues come up. Like one of them is that I was recording audio was coming from the camera and from my mic, so they were hearing the audio twice. So just getting shaking out little things like that. So to give you an idea of what I'm doing, I am making a quick presentation that I'm going to record about where to terminate first hops in VRFs. It's a question I've seen come up a lot recently, and I think it's valuable to make little presentations like this. And I'm just showing, this is just a recording of this, showing the process of making the content for this. So I do a lot of content development, specifically for courseware development for classes. Like I've written classes for Cisco, for Arista, for A10 Networks, and a bunch of other networking companies, and I do my own stuff as well. Make skydiving presentations, and this is how I'm making one of these. And one of the first things, well, a couple of things. When I'm also using this as the rubber ducky. If you've ever heard of rubber ducky development, when a developer, like a code developer, wants to write some code and they're having some trouble, they might put a rubber ducky on their desk and they explain what they're doing to the rubber ducky. And then that process of explaining it to someone can resolve a lot of issues. And this is kind of what I'm doing here, using the live stream as a rubber ducky. Plus, I thought it might be helpful for people to see what the process is like for making this kind of content. So this is not going to be a super long presentation, but of course, like anything, it takes much longer to make the presentation than it does to give the presentation. So I would expect this to be about a 10-minute presentation, probably take about 2 hours, an hour to 2 hours to make the presentation. A couple of things before I get started. One of the things I'm experimenting with is changing the coloring scheme that I normally have done. So for the past 20 years, when I've done PowerPoint presentations, I've been very adamant about doing black text on a white background. And the reason for that is most of the time when I was teaching IT stuff, I was using a projector. I was going to an office, whether it was the vendor's office, like Cisco's offices, or a customer's office, I was using a projector. And if you've ever done that a lot, you know that projectors vary widely in quality. So some are like brand new and some are using like 10-year-old clapped out bulbs that says replace bulb, and it's been like that for 10 years. So it's important to have contrast, because if you don't have contrast, then it's going to be a problem for people watching the or reading the slides. And you want to always remove the barriers whenever you're teaching. You want to remove the barriers that students might have into absorbing the content. One of those barriers is bad audio. So that's something that a lot of people who are switching from live content to recorded content have struggled with, is terrible audio. I have a very nice mic setup right now. If you have any questions, you can put it in, just ask in the live chat, or you can make a comment on the video when I post it later. If you want to know what I recommend for these kind of audio things, because if bad audio takes a lot of processing power in your brain to listen to, it's got to filter it out, and that removes some cognitive ability on your part. So you're concentrating on just figuring out what they're saying versus absorbing it. So having really good audio is important, which is ironic because I messed up on the first version of this because I was doing double audio and they were slightly offset. So this audio I think is working fine. The other thing is just making sure that the PowerPoint or slides, Google Slides or Keynote, whatever you're using, is not distracting from the content. So that's a big pet peeve of mine, is when people use terrible PowerPoint templates. I just keep it simple. So very simple, maybe a little bit of branding. I don't have any branding for this stuff, so I'm just going to keep it very simple. I can always, in like an editor, I can always throw a logo into the corner or something like that. And my face is part of the branding, my beautiful face. And then of course the quality of my audio is part of my branding, and as I knock my microphone, and the quality of the content is part of the branding too. So I'm experimenting with doing a different color scheme because the age of projector presentations is pretty much over. Like you still might do it every now and then. At least for my job, it's now all either live on like Zoom or WebEx, or it's somewhere else like YouTube or Vimeo or something like that. So it's always going to be, people are not looking at this on projector screens anymore. They're looking at it on their TV, their laptop, their tablet, their phone. In that scenario, I think a darker background with white text is going to be better. But we're going to see. I'm going to play with this. So I'm not as used to this. So some of my color choices might be, I might need to refine some of my color choices, like how I do the outlines. Like, do I want to do a lighter outline or a darker outline? It's, it's kind of up in the air on that one. Oops. Yeah, so it's hard to tell. Anyway, we'll just play around with it. So the question is where to terminate first hops and VRFs, and that's a question I've seen a lot in the networking world recently, especially on the networking Reddit. Is what's going to be your first hop on a data center network? Is it going to be the switch? Is it going to be a firewall? Those are generally the two options. So is it going to be the switch with an SVI, or is it going to be the firewall? And I wanted to talk about the issues and the benefits and drawbacks of each. And then, so maybe I'll throw in a problem statement. Like, what are we trying to solve here? So I might put it in this format. Problem statement. I'm just making big text here. Make sure to, where is the best place to terminate, to have a first hop? Is it a firewall or a switch or something else? So that is going to be the problem statement, just so everyone's on the same page with what we're talking about. So where's the best place to have a first hop? Is it a firewall or a switch or something else? And then we'll go into a quick discussion of what a first hop is, so everyone knows. A first hop is going to be an endpoint. So we'll define an endpoint as, we'll do a quick definition of an endpoint. An endpoint is any discrete compute node. So it could be a server, bare metal, could be a virtual machine. In a data center, it's probably going to be a virtual machine. Could be a container with a discrete IP address. It could be a tablet or a phone on a wireless network, a desktop, a laptop, something like that. Something with an IP address and MAC address combination. And then we're connected to a layer 2 segment. And if I want to get out of my layer 2 segment, if I want to connect to a network that's not this 10.1.100 network, then I need a gateway, a default gateway. In the server world, we generally don't call them first hops. We call them default gateways. In the networking world, we call them either default gateways or first hops, but they're the same thing. Since endpoints don't run a routing protocol, they don't have a next hop. They don't determine the next hop dynamically. We just have to set it manually, and that's usually just the default gateway. Or they get it from the DHCP server or automation or whatever. So, but we need a default gateway, a first hop. And so that's what we're talking about where to terminate it. And then, so I've got a leaf spine topology here, which is the most common, I think, that we see in data centers today, at least medium to large. In fact, you know what? I think it actually might be beneficial to show the two different types. I'm gonna look around for some other slideware that I've got. I really try not to reuse my slideware, or at least reuse it as little as possible. I know I've got this somewhere. Yeah, here it is. Let me try something real quick. For privacy reasons, I'm just going to turn that off for a second. Okay. Yeah, I didn't have Dropbox turned on, so try that again. It's for a generic EVPN course I was doing. So this is what it looks like. So this is a, so maybe I want to use this aesthetic. So copy this. Make a couple of slides. So it's all grouped, so I'm going to ungroup it. And then I'm going to change the outline to something lighter, just to give it more definition. Yeah, I think that looks good. Just straighten this out. Okay, so this is a traditional leaf spine topology. That's what I was doing here. And then the other one is this, which is the core aggregation axis layer, the more traditional way of doing things. I didn't get any of the... Oh, it's all grouped here, so that's nice. I need to make sure that these are white. They match the, so Optos. Yep, so that's good. So it matches the font there. And then I've got to do the same thing for this is I will ungroup it. Ungroup. There we go. So I need to change their outline. You know what, that looks better than this. So I'm gonna do that. So, you know, these are little tweaks I do all the time. Trying to figure out the right color scheme. Again, we're trying to make it so that the content is easy to read and doesn't distract. If you're like squinting or trying to figure out what is what, then that's distracting. If things are different colors and different fonts, that can get a little distracting, but we want to make sure that we're undistracting. So core aggregation access layer, this font needs to be bigger. So I'll just make that bigger there. And then something to denote what is layer 3. So this is all layer 3, and I need to make that white. I should figure out in the slide master how to make the text by default white. And customize fonts. It's not there. Colors. Customize colors. text background. Yeah, so text be white. Oh, the background is going to be, no, background's going to be that dark color. Something like that. And you can pick the different colors. Call it 21. I just undid all that. You know what? I'll figure that out later. So this is layer 3 only. Maybe I'll put an arrow. Let's do an arrow. Maybe send it back. And I'll do this. So in the aggregation layer, we'll have the first hop. And the access layer is layer 2. So this is the more traditional network. I'm going to move this off to the side. Or I'll do this. I'll leave it in the center. Do it that way. I'll group these just to make it easier. Line them up to be consistent. Group them. So this is traditional 3-tier architecture. So this is what we've been doing since VMware came on the scene in 2005. Is something like this. There's also, so that'll be leaf spine, and then there's also a collapse core. So a collapse core is when we take the core and aggregation layer, then put them into a single device. Because when we got multi-layer switches, we didn't really need a separate core layer. Let's call this a collapsed core. I can just borrow these. Shorten this up a little bit. I'll group this, and then I'm going to hold down the shift key and shrink it while keeping the dimensions, the ratios the same. Because I want to make a little bit more room for some descriptions here. Oh yeah, the collapse core. So yeah, that's that. So the collapse core, and this is supposed to be for the other one right here. And I will also highlight all that, unselect those. I will group. Try that again. I'll group it and then hold down the shift key so I can shrink it without changing the dimensions. Because if I don't hold down the shift key and I shrink it, I can make it skinnier or taller or whatever. But I don't want to do that. I want to maintain the perspective or maintain the... Some vendors will actually call this leaf layer, even though it's really access, or core spine. Kind of depends on the vendor, but the first hop is here, and then the access layer is still just purely layer 2. So when we're talking about where to put the first hop, this is going to be relevant to these 3 architectures because this is generally what you're going to see in the data center. You're either going to see the 3-tier architecture, you're going to see a collapsed core, or you're going to see, I don't need this, stop it. Or you're going to see the layer 3 leaf spine. So this is a layer 3, or this will be leaf spine, also known as a CLO network. It's not capitalized. Some people, I think most people are figuring out that it's not COLS, and it's not capitalized, or it's not an acronym. So it's capitalized because it's a person's name. I think it was Michael Clow in the 50s came up with this kind of general concept for for telephone networks. So this kind of doesn't really resemble this anymore, but sometimes we might call it a CLO. This is a 3-stage CLO. And then you can also have a 5-stage CLO. It's 3-stage CLO because 1, 2, 3. You're 3 hops away. No more than 3 hops away. So in this case, we are first hop Anycast. Now I say EVP and VXLAN, but you can also do this with ACI, which is not EVP and VXLAN. It's a combination of some other stuff. So I don't know if it's worth making a distinction there. And I'll copy these things. Cutting and pasting. And they're not called access switches or core. It's just spine and leaf. So these are generally when we're also, this is when we're doing first hops on the switch, on the switches. So let's do a first hop choices. We can do it on the switch. We can do it on the firewall. Copy these 2 things. I'll do it and see if I'm happy with it. So I need another icon for a firewall. Let's see if I can use, let's see if this Copilot stuff can actually help. Is there Copilot on here? Man, it's always pushing Copilot, and then the moment I actually want to use it, it doesn't have Copilot. What the heck happened to it? Help. Shape format. Because I want to see if it can make me a fire icon. So I can just throw it on here. So I'll do shape fill. That's a little too loud. That's better. And the outline, even darker, or do I want to do a little lighter? Yeah, so this will be my firewall. Oh, there's Copilot. Make professional. Yeah, don't need to do that. Center, and then I'm going to make this bigger. So first hop choices, we do it on the switch or we do it on the firewall. So just to review the traditional 3-tier architecture, leaf spine and collapse core. And then our first chop choices. This may not be making a lot of sense in terms of the flow, but I can go back and sometimes I just need to get the slides out and then I can reorder them or adjust them as I need. But I know I'm going to need a slide about first hop choices. I know I'm going to need a slide about the 3 different architectures you're likely to run into in the data center. And we need to have a discussion about, another discussion we need to have is hardware forwarding and software forwarding. I don't know why they're in quotes. They don't need to be in quotes. So hardware forwarding, generally, forwarding is done in the ASIC, also known as a forwarding engine. So Broadcom, Trident series is an example, or Cisco One. So these ASICs that are in most of these hardware switch, or all of these hardware switches rather. So in a switch, the forwarding is done on the ASIC or the forwarding engine or the NPU, network processing unit, depending on what you want to call it. I think generic. I don't like calling it the ASIC because ASIC is such a generic term. It can mean a lot of different things, whereas forwarding engine is a little bit more specific to the networking world. So forwarding is done in the ASIC. The Broadcom Trident series, Cisco One are examples. Allows line rate out of every port for most or all packet sizes. So some switch platforms don't let you do full line rate for every packet size. Some of the really small packets you can't quite get line rate out of, but practically speaking, we're getting line rate out of every port. And then software forwarding is done via CPU and RAM. Done via CPU. Forwarding table is stored in RAM. So I made to the thing. So forwarding is done via ASIC. Forwarding table is stored in CAM, TCAM, or equivalent. So it's not always TCAM now. Sometimes it's high bandwidth memory. Sometimes it's some other stuff. So I'm just going to say CAM and TCAM. Much more limited in. So this is much more limited in functionality. Much more limited. Functionality is nearly limitless. Cannot do line rate out of many ports. So the hardware forwarding, that's going to be much faster and much more efficient. And I'll give an example here. Just the difference. Difference in forwarding rates. I'm just going to pick 2 vendors. I'm going to pick, let's do a Cisco 9300. So I'm going to look up a picture for Cisco Nexus 9300. It's a common switching platform. work. There we go. I just need a picture of the switch. Nope, that's not a whole picture. There we go. It's not. Yeah, so that's going to be a problem because I used to use white backgrounds, but now, unless the image is a PNG with a transparent background, I'm gonna have to do some. So that's one of the reasons why I'm doing this, is to see what the problems are, what the issues might come up with. I didn't think about that. So now if I pick an image, there we go. So I need something with a background image. So this is 32.400 gig switch. What's the model number? Yeah, so this is a 9332. So I want to put something in here to denote what it is, so people can check my work. So this is a Cisco Nexus 9348D GX2A. Way to name things. And I'll just look up roughly what the power supplies are, because I want to compare. Wait, did I get the right switch? 9348? 93, no, that's 9332. That's not the right number of ports. GXB. And I'm looking for power supplies. So how much power are we supplying this thing? 1500 watts. So that's the maxed out. So it's probably not going to run 1500 watts. So let's say about 1000 watts. So if I give it about 1000 watts, what am I going to, how much forwarding throughput am I going to get, just to show off like what the insanity of these hardware forwarders are? Because what I want to do is convey how much better switches are at forwarding traffic than firewalls, because it is ridiculous. $1,500 watts. Typical power is 638. So so let's do 650 typical load. No, I don't need to say that, because we're just spitballing here. We're just doing back of napkin math, so we don't need to be precise. And then what's the throughput? We just do some quick math. 25.6 terabits. Yeah, so that's what it is. And we get 25.6 terabits per second of throughput. Because that's accounting, that's because I think there's line rate out of every port. Pull up a calculator here. It's 32 ports of 400 gig. So 32 times 400, and then we multiply that by 2 because it can do full duplex. That's where we get 25.6. So that's 25.6 full duplex. Now let's pick a firewall. So I'm going to open this up in a different window here so you can see what I'm doing. So I'll do Fortinet firewall. I'm a Palo Alto. No, we'll do Palo Alto. I don't really work in this field, so I don't know the different models. Let's pick something. Let's do data center. Oh, this website's annoying. Yeah, something like this. PA 5445. That looks about right. I'm just picking some models here. And then here we've got some nice figures. I can just use that. That's actually perfect. And that's a white background. So I want an image. We'll do an image search for a PA 5445. Look in the different Palo Alto networks. Ugh. I really don't want to have to open up PowerPoint. Or, I want that one. Nope, that's a white background. Stop it. That one, nope. I need a transparent background. Yeah, this is going to be a problem. It's going to be an extra step where I have to take. I'll just go ahead and use this one for now. But I know that it's 90 gigabits per second. Oh, what happened to... Yeah, I deleted that by accident. There we go. So now I want to see power supply. So specifications. I don't have to be super accurate here. I just want to get in the ballpark. So power consumption, actually 630 watts, so about the same thing. And it can do 90 gigabits per second of appware performance, depending on how you license it. That's a big difference. So this thing's double the size in terms of how much space it's taking, but for about the same, power and double the size, because one's 1 RU, one's 2 RU, I think. I think that's 2 RU. That's a huge difference. What's the percentage? 256. So that's gigabits. So 25.6 terabits. So that's 25,600 gigabits per second divided by 90, or rather I want to do 90. I can just invert it and do an inverse. Yeah, so it's like not even 1%. Do that math again. So it's 90 divided by 25 points, 90 gigabits divided by 25,600. Yeah, that is bonkers. I didn't realize it was that bad. Now, this is a 400 gig switch. Not every switch is going to be 400 gigs. Maybe I should use a 100 gig switch just to be a little bit more realistic. Or I should use You know what? I should use a 25. I should use a top of rack switch because this is not a top of rack switch. All right, I'm going to redo this. You know, this is the process. Sometimes I'm like, you know what? I should go back. So let's do 93, 180, YCFX3. I think that's the top of rack du jour. Is there anything more newer for 48 ports? I don't think so. So yeah, that one is going to be. Oh, that's back. Cool. They did a. Thank you, Cisco. Actually, these are lower power. Typical power for the 93 180. So this is a Cisco Nexus 93 180 YC. I think this is kind of the de facto Nexus 9000 top of rack switch. So if you give it about typical power on this thing is 325 watts. That's actually less than I thought it would be. And it gives you how much throughput? I can do the math, but it probably says so in the data sheet. So I'm looking at, I don't want to do your the bandwidth switch supports 3.6 terabits per second. Okay, so that's a little bit more. 3.6 terabits per second and 90 gigabits per second. So let's do some math again. Let's see what the percentage is. So 3600 divided by 90. I'm sorry, 90 divided by 3600. So about 3%. So it's about 3% of the forwarding rate. So I just want to drive that point home. How much better, and I need this to be like bold. So almost twice the power output or twice the power draw, and could do 3% of the forwarding rate. So I'm not saying that you should always terminate on a switch. I'm just saying that the performance, the forwarding capacity that you get with terminating in a firewall is significant. Like there's a lot less forwarding capacity. In terms of layer 3 forwarding for our next hop, most switches are going to be line rate. That's going to be a limitless resource, basically. And the reason is because the Palo Alto and most of these other firewalls, and it's not a Palo Alto thing. They're all about the same. So FortiGate, Fortinet, FortiGate, whatever, Cisco, Firepower, whatever they are. Again, I generally don't work too much in that industry. They do all the processing in the CPU and RAM. So a packet comes in, and they've got connection tables, and they've got to do. Sometimes they do application-aware forwarding, so they're looking at the actual payloads. So there's a lot more limited forwarding rates that you're going to get out of these things. And it's just the nature of what it's doing. So I'm not saying it's better, or it's not saying it's like a ton worse. It's just saying that there is a big difference. That's app-aware forwarding. But generally, that's what you're using this for, is the app awareness. So, but let's take the flip side of that, and we'll do difference in capabilities. Because there's a huge difference there, and this one goes more towards the firewall in security capabilities. So the 3.6 terabits per second, what that gets you is stateless ACLs. So I think we probably should talk about what a stateless ACL is. Switches can evaluate traffic based on layer 2, say generally. Multi-layer switches. Multi-layer switch means it's a switch that can route and a switch, generally speaking. Multi-layer switches. I have to say generally, because it's networking, and sometimes there's going to be an exception. There's always exceptions in networking. But generally, multi-layer switches can evaluate traffic based on layer 2 headers, layer 3 headers, and layer 4 headers, and a few other headers. When a packet enters a switch, we can evaluate. We can allow or deny based on those parameters. But switches don't remember what it did with any other packets. So no state table. Switches can't go into payloads, generally. And switches can't build state tables build state connection tables for ACLs. So there's a lot of limitations that we get. Now, the benefit of this is we get line rate forwarding and we get line rate ACLs. So we do line rate but stateless ACLs. So we can, if I want to allow just port 80, anything else other than port 80 or port 443, for example, that'll get forwarded. No matter how many rules I have in the ACL, it's always going to go through at line rate with no additional latency. But we cannot build state tables. We cannot go into payloads. We're not doing app aware, anything. It's just frame comes in, packet comes in. We look at the layer 2 header, the layer 3 header, layer 4 header, and that's it. Anything beyond that is a mystery. So maybe I'll shrink this, and then I'll draw like a frame. So this is a L layer 2 header. We can look at the layer 3 header. And the layer 4 header. And the rest is payload. Make that purple. And we have no visibility into the payload. There's some switches that can do some, like, you can look at the first couple bytes of a payload, but that's generally not, it's not useful for the security purposes. So that's what a stateless ACL is. So generally, multi-layer switches can evaluate traffic based on the layer 2 headers, layer 3 headers, and layer 4 headers. When a packet enters a switch, we can allow deny based on those parameters, but switches don't remember what they did with any other packets. So that's what a connection table does. It remembers what we did with related packets. This is part of a TCP connection. We don't have the ability to do that in switches. And they also can't go into payloads. Whereas firewalls can vary widely in capabilities. Generally, firewalls can allow deny based on L2, L3, L4 headers. And they can build state connection tables. You know, an example for that might be the benefit of having a connection table is if I see a TCP segment come in with an established bit, the switch is just going to assume that a TCP connection has already been initiated. But if a packet comes in with a TCP connection established bit, but the firewall doesn't have a record of a TCP connection based off the those port combinations, then it's going to reject the packet. So the switch would allow that kind of packet, the firewall would deny that kind of packet. So there are some basic things that we're not going to stop on a switch that we can stop on a firewall. Many firewalls today can go into payloads and are app aware. So they can look at HTTP, HTTPS traffic. So if they terminate the certificate, look for malicious payloads, cross-site scripting, XML, SQL injections, that kind of thing. So they can do that kind of thing depending on the device. So it has the full capability to look into it, but you pay a pretty big performance penalty, not performance penalty. You pay a big scalability penalty there because more firewall rules can mean more latency, more limited forwarding capacity. So the latency on a switch is going to be very, very consistent. You're going to have, unless you've got congestion, you're not going to, the number of ACLs are not going to affect your latency, even if you have congestion. So ACLs are not a factor in congestion or a factor in latency on a switch. But on a firewall, the number of rules might start to increase your latency. The number of, if you're near your capacity, your latency might start to jump up. These are very generalized things. So now we set the stage, and now let's talk about, where do we put it? And I'm going to use the example of the leaf spine topology because that's probably the most common that people are going to be introducing, but it works for anything. Title only. So I was thinking about how am I going to handle these images when I use product images. Probably I'll just leave them like this and just do a batch. I'll go in like on a separate pass before I'm ready to present this. I'll go in and make a, just go in and do it all at once because there should be only a couple of them. So, first hop on switch. So if I do the first hop on a switch, and I've got, we'll do a diagram of host 1, 10, 1, 100, 11. Gateways 10, 1, 100, 1. So DGW is default gateway. Also known as first hop. Host 2. Be in a different subnet. We'll just show them plugged into a single switch. You know what? I'm going to keep it simple. I'm going to actually get rid of, for this one, I'm going to get rid of the peer links. I'll use the distribute. Size and position. I want to align them, distribute horizontally. There we go. Just to get them easy, even spacing. So the first hop, so with an Anycast gateway, the first hop is going to be everywhere. And maybe I want to do a little thing on that. Make that a little smaller. Make that a little smaller. Because with an Anycast gateway, which is really nice, the first hop is everywhere. It's a pervasive Anycast gateway. So I want to align these, arrange them, align them, align the middle, and then I want to distribute them. These tools are really nice. Distribute horizontally. Okay. Then copy and paste. So depending on what VLAN I'm on, that gateway is going to be there. So what also I might do is I might do an animation. Animations are perfectly fine in PowerPoint. It's the transitions, stay away from. Don't touch, never touch this. Never do transitions. They're stupid and they serve no purpose, and they're stupid. Transitions are stupid. If you're doing a marketing slide deck, then that's, whatever you think is appropriate for that. But for a technical slide deck, transitions are absolutely freaking stupid. There's no reason to do them. They're just annoying, and they make it more difficult to work with a PowerPoint deck or any kind of deck. Stay away from transitions. Have I made myself clear on transitions? So I'll do an animation. So they're going to appear. Actually, you know what? I'll do this. So they'll appear, and then the next row will appear, and then they will all disappear. Because I want them to go away. And this got caught up in the animations. Okay. So like this is what it would look like. Nope. Shoot. Well, that's fine. I want them to all appear. Try that again. I need multiple animations here. So I want these to fade in. And then I want these to fade in. And then I want a new one. Where they all fade out. I'm going to add animation, fade out. There we go. That's what I wanted. Let's try that. Swap them. So yeah, the Anycast gateways, they fade in, and then they all fade out, and then I can discuss the rest. Perfect. Okay, that's what I wanted. And then maybe I'll have something else too. I'll put in a text box here. Do I want to do this with text inside of it? Link speed between hosts is the only link speed. Traffic can flow between hosts as fast as link speeds will allow. And congestion. Because, I mean, we could be limited by congestion if there's congestion on the network. But basically, if the first hop's on the switch, we're going to be able to do line rate from host 1 to host 2. So as fast as they can go, as long as we have the capacity, they can just completely go, unload onto each other. And that's true even if whether it's on the same switch or a different switch. So it doesn't matter there. Now, if we do a firewall, so let me get the icon for the firewall here. So in a firewall situation, let's make this a little smaller. You know what? I also want to make this, copy this and put it in here. This should be raised a little bit. They don't need to be this low. Get rid of it there and put this one here. So that gives me more room to put it in here. So my firewall is plugged into here. And all my gateways . So for VLAN 100 and VLAN 200, so now all traffic so all traffic is protected by a firewall, but is limited to firewall forwarding capacity. So the point here is that when the first hop is the fabric itself, the switches, the limit, there's no real limit in terms of how much traffic we can send between the two of them. But when traffic has to go through a firewall, it becomes a bottleneck because everything is contingent upon going through that firewall. So I might do so from traffic here, 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 here. And then I'll make that a Make that a weightier thing. I'll make that a bright color. And I'll put some arrows on both sides. So now all traffic has to go through that, and then it has to go through that on the way back. So now you're bottlenecking. Firewall as a bottleneck. So we really have a bad choice here. Do we have like amazing capacity? Do we have amazing? We have amazing capacity if we put it in the switches, but we only have rudimentary security capabilities. Or if we do a firewall, we have amazing security capabilities, but we have rudimentary forwarding capabilities. So it really is a Sophie's choice here. Roxy asks, do you ever worry about accessibility with your colors that you choose? Like, for example, reds, greens, and color blindness? Yeah, I do. I don't have a solution for it. And I tried, like, accessibility is an important question, I think. To try to make the content available to as many people as possible, to a wide variety of people as possible, despite their status. For example, I concentrate a lot on English comprehension, to use simple language, to try to speak slower when I'm teaching. I can sometimes speak fast, especially when I know the audience is going to be international. I used to go and train in lots of different countries. Like I'd go to India to train, I'd go to Thailand to train, and I would speak slower and use more simple language. So I think about that in terms of accessibility, just to make sure that people can, most people can understand this as possible. And contrasting colors, I think, helps out a lot with the color blindness thing, but I haven't really delved too deep into it. Like, what happens if all color were to go away, or people might be red-green colorblind, so they might look the same. So I don't have a solution for that. If anyone has any suggestions, oh, my battery just died on my. I'll be right back. There we go. All right. So it's, yeah, I don't have a solution for it. I don't, I try to use contrasting colors, but that's more of a making sure that it's easy to see for everyone. I'm hoping that the contrasting colors and contrasting tones will make it easier for people who might have color blindness to see. And then YouTube actually has a really nice feature that it can auto, it's not always perfect, but it can auto caption the videos. So just a nice thing that YouTube does by default. Okay, so traffic between hosts is protected by the firewall, but is limited to firewall 40 capacity. So the firewall becomes a bottleneck. So that's the trade-off. And I'll just say that's the trade-off. Switches forward at line rate, but provide rudimentary security capabilities. Firewalls provide excellent security capabilities. but rudimentary forwarding capabilities, capacity. But a much lower and can become a bottleneck. So you could try to scale out your firewalls. You could buy more firewalls. So some approaches. Let's talk about different approaches to the problem. One is to just use a firewall for north-south traffic. So traffic that leaves the fabric. So that's an option. Is you'll just do forwarding. It'll be a free-for-all inside the fabric, inside the network, and then you could do maybe some ACLs, and then everything else will go to, and then coming in and out of the data center will be a firewall. So that's an approach a lot of people choose. Another approach is just to spend the money and buy lots of firewalls. There's some scalability approaches you can take, but you're just going to have to buy a lot of firewalls to get the capacity that you want to inspect all east-west traffic. So maybe I need to put a little primer on what north, south, east, west is. So our north-south traffic would be this. So I want to make that so north-south traffic is traffic to and from external networks. I'm going to do this. And then put it on its side. I think that makes more sense. And then get my host here. Well, let's start over. This is east-west. I think most people in the data center would know this, but again, this is I'll just err on the side of ignorance here. Let's make up numbers here. This does show the traditional MLAG connections. Or it could be something different. It's usually MLAG these days. That trill. There we go. You know what? I'm going to rename these endpoint 1 and endpoint 4. So that's what EP means. Do I really want to change that? We'll do it. So we can just use a firewall for north-south traffic that leaves the fabric. Just spend the money and buy lots of firewalls, inspect all east-west traffic. Or there's a compromise, and this is kind of where I'm leading everyone to. Compromise. Some traffic is some east-west traffic is firewall forwarded. Some is switch forwarded. So what does that look like? Compromise, VRF. We can separate security zones via VRFs. Intra VRF traffic is switch forwarded. Inter VRF traffic is firewall forwarded. This is the approach I think I tend to see the most. So we might have a VRF. So I'm going to set this for white, and then I'm going to format the shape, text options. Put this at the top. So this will be VRF DMZ, VLAN 10, VLAN 20, VLAN 30. .1, 30.1. And the VRF database. So it'll be VLAN 11, 21, 31. Shrink those down a little bit. So then traffic inside of these VRFs, and we just put them in different, we can put different VLANs in different VRFs. And then traffic outside of them, if we want them to communicate, we have to go through a firewall. Where's our firewall icon here? So this is a nice compromise. It gives you the best of both worlds, really. You know, ideally, we'd love to have all the protection we could between subnets, but that's just not, usually that's not feasible for most environments. So we'll do a firewall. And this could be the same firewall, or they could be different firewalls, depending on how I want to determine things. And then we'd have the internet. So I'll put the internet here, or the external network. I'll make these a different color, brighter color for more contrast. Make this white in the middle. So I think that's a good presentation. I think actually that's pretty good. You know what? I may not even care about the fact that there's a white background here. I might be inclined to fix it, but I think this is a good presentation. I'll go through it and see if I need to change anything, but like, this is how I make content. This is how I make courseware, is I kind of talk it through myself and think things through, and yeah. And this is the quickest way I can do it too. So I made 20 slides. So this is an hour-long presentation probably. I made 20 slides. It's at least half an hour. But I made 20 slides and it took me about 2 hours. So that's about the fastest I can go. So it's tough to make content. So, I mean, if you have any questions, you can put them in the comments down below. Roxy had a great question, and thank you for watching.